Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Gustin Rahma Lutfiana and I'm from International Class of Mathematics Education 2019 and my ID number is 41014190101. Okay, today I'm going to explain about how to solve a linear programming problem using geogebra and a ruler method. And I have a problem here. The problem is like this. I'll read it for you. A public relations director for a homeopathic is seeking to advertise her company's product on two different websites. One is a medical parts supplier and the other is a fitness e-sign or web-based magazine. The medical parts supplier website receives on average about 120 hits per day per page, while the fitness e-sign receives about 200 hits per day per page. The daily cost to advertise is $100 per advertisement and $150 per advertisement respectively. The director would like at least 15 ads and is able to allocate up to $3,000 for advertising. At least 3 ads should be placed on each website. How many ads should be placed on each website to maximize the potential number of readers? And this is the solution. First, let X is the number of ads in medical parts supplier and Y is the number of ads in fitness e-sign website. And the constraint is, before that, I've already turned this into a mathematical model like this, and I've got the constraints. The first constraint is 100x plus 150y is less than or equal 3000, and x plus y is greater than or equal 15, and x and y is greater than or equal 3. And the objective function is L is equal to 120x plus 200y. Okay, now we are going to use GeoGebra to solve this problem. The first thing that we have to do is write down all of the constraints here. The first constraint is 100x plus 150y is less than or equal 3000. Okay, and we use this symbol. And the second is x plus y is greater than or equal 15. And x is greater than or equal 3 and y is greater than or equal 3 also. Okay, zoom out this to see the visible area. As you can see, the blue area is the visible area of this problem. So the next thing that we do is turn all of these constraints into an equation. The first is 100x plus 150y is equal to 3000, and x plus y is equal to 15, and x is equal to 3, and y is equal to 3. Okay, as you can see, the line name is equation 1, equation 2, etc. So we have to change it. We use this select setting and then change it into value. Okay, so this is changed like this. Do the same thing to the second equation setting, and then this is value, and drag it here. And for the third equation, this is settings and value. Okay, this is x is equal to 3, and for this equation, okay, and this is y is equal to 3. After we know all of this, we have to find the intersection point between each line. So the first we have to do is press this intersect. So we have to choose two objects. In this case, we have to choose the line, two lines, so we know the intersection point between two lines. The first point is here, so choose this line and this line, so we got the A. The A point is 3,12, and this is B point. The second point is we press this line and this line, so we get B. Do the same thing for the third point and the fourth point. Okay, we have all of the intersection point in the corner of the visible area. So now to know how to maximize the objective function, we should write the objective function here. So I'll write the objective function 120x plus 200y is equal to L. Okay, and this is the line, this is the objective function line. We can change the name to do the same thing like before. This is value, so this is the objective function line. As you can see, this is if L is equal to 1, so we have to change the interval of L. This is from 0 to 5,000. Okay, so how do we get the maximal value of the objective function? First, we have to press this button. Okay, before we do that, the maximum point, the optimum point is the end of point. I mean, here the last point that crossed by the line. Okay, we press the play button. The first is point B. The point B is the first point that crossed by the objective function line. So this is not the maximal point. This is not the optimum point or maximal value of the objective function. So we play this button until we find the last point that crossed by the line. This is the objective function value of point A, and this is for point C, and this is for point D. As you can see, the point D is the last point that crossed by the line, so D is the maximal point, D is the optimum point to find the maximal value of objective function, or to maximize the objective function. So we know that the x, we have to back here. Okay, we know that to maximize this objective function, the x value must be 3 and the y value must be 18. So we know that the maximum value of the objective function is 3,960, and it is occur at D point 3,18. Okay, and that's all for me. That's all for today. Thank you for all of your attention, and I hope it will help us to study linear programming problems. And I'm sorry if I have some mistakes in my explanation. And thank you, and wassalamualaikum warahmatullahi wabarakatuh.